This is section 6.5, solving polynomial equations. Our objective today is I can solve polynomial equations. Polynomials that cannot be factored are called prime polynomials. In example 1, we're factoring each polynomial. If the polynomial cannot be factored, we're going to say that it's prime. So looking at example A, first, we notice that we can factor out a GCF. So looking at our two pieces, 16x to the fourth and 54xy to the third power, we know that we can go ahead and factor out a 2x because that's what they have in common. And then what we're going to have left, we're going to write back on the inside. So we're going to have 8x cubed plus 27y cubed. And now we can see that 8x cubed and 27y cubed are both perfect cubes. So we can factor using the sum of two cubes. So we can go ahead and say 8x cubed plus 27y cubed is equal to parentheses 2x cubed plus parentheses 3y cubed. So using our formula, we can go ahead and say 2x plus 3y multiplied by 2x squared minus 2x times 3y plus 3y squared. And then we can go ahead and simplify. So we have 2x plus 3y times 4x squared minus 6y plus 9y squared. And then we still have this GCF that we have to include in our final answer. So we'll have 2x times 2x plus 3y times 4x squared minus 6y. Oops, and that should actually be a 6xy because we had 2x times 3y. Plus 9y squared. And that's going to be our final answer. Looking at example B, we see that the first term is a perfect cube, but the second term is not a perfect cube. So we can't factor this polynomial using the sum of two cubes pattern. We also can't factor using quadratic methods or greatest common factor because we don't have a greatest common factor that we can take out. So therefore, since we can't factor this using any of the methods, this one's going to be a prime polynomial. In example 2, we're factoring the polynomial. And if the polynomial can't be factored, we're going to say that it's prime. So looking at our first example, we have 8ax plus 4bx plus 4cx plus 6ay plus 3by plus 3cy. And the first thing we're going to do, we're going to group this so that we can find a GCF. So I'm going to go ahead and group these two sections. And from these two sections, I can find a GCF in both of these. So from the first section, I can pull out a 4x, and I'm going to be left with 2a plus b plus c. And then in the second piece, I'm going to be able to pull out a 3y. And then that's going to leave me with 2a plus b plus c. And so here we can see that the two pieces that we're left with on the inside after we take the GCF out, those are the same. So we can go ahead and write our two factors, one made up of our two GCFs, so we have 4x plus 3c as one factor. And then as the second factor, we have those two pieces that are common, so 2a plus b plus c. On example B, we have 20fy minus 16fz plus 15gy plus 8hz minus 10hy minus 12gz. So again, we're going to group to be able to find that GCF. Okay, so I grouped my terms together, and now from the first piece, I see that I'm going to be able to take out a 5y. So I'm going to pull out the 5y, and on the inside I'm going to be left with 4f plus 3g minus 2h. In the second piece, I'm going to pull out a negative 4z. Now if I pulled out just a regular 4z, my two inside pieces wouldn't match. That's why I'm going to pull out the negative. So now I'm left with 4f plus 3g minus 2h. So now I'm going to go ahead and write the two factors I'm left with. One coming from my outside pieces, so I have 5y minus 4z as one piece, and then 4f plus 3g minus 2h for my second piece. Looking at example 3, we're factoring each polynomial, and if the polynomial can't be factored, we're going to write prime. On the first example, we have x to the 6th minus y to the 6th. And this polynomial can be considered the difference of two squares or the difference of two cubes. The difference of two squares should always be done before the difference of two cubes, because that's going to make our factoring a lot easier. So if we go ahead and write this, we can say that x to the 6th minus y to the 6th is equal to x cubed plus y cubed times x cubed minus y cubed. So now that we've done that, we can go ahead and break this down even further using the sum and difference of two cubes. So we can go ahead and say x plus y times x squared minus xy plus y squared times x minus y times x squared plus xy plus y squared. And that's just coming straight from those formulas that we have. Looking at example B, we have a cubed x squared minus 6a cubed x plus 9a cubed minus b cubed x squared plus 6b cubed x minus 9b cubed. And so with 6 terms, we want to go ahead and factor by grouping first. So if we go ahead and do that, we'll go ahead and put our parentheses on here. And we know from our first piece we can take out an a cubed, and we're going to be left with x squared minus 6x plus 9. And from our second piece, we can take out a negative b cubed, and we're going to be left with x squared minus 6x plus 9. So then we can go ahead and write our two new factors. So we have a cubed minus b cubed as our first factor, which came from our two outside pieces. And then our new inside piece, or our piece that comes from the other two, are just these two factors here. And so we had x squared minus 6x plus 9. And then we want to go ahead and see what can we do to the rest of this. So we can go ahead and use the difference of cubes to be able to break this down even more. So I'm going to have a minus b times a squared plus ab plus b squared. And then I'm still going to have my x squared minus 6x plus 9 on the end. And now, using perfect squares, I can go ahead and break this down one more time into our final answer, which is going to be a minus b times a squared plus ab plus b cubed times x minus 3, and we could have x minus 3 with it as well. We could also write our final answer, just get rid of the x minus 3 that's second, and we could go ahead and just write squared on the end of the x minus 3 instead of writing it twice. Either way is okay, either way I would accept. Now we're going to go ahead and look at quadratic form in example 5. And they want us to write each piece, or each of the examples, in quadratic form if possible. So if we have 150 n to the 8th plus 40 n to the 4th minus 15, we can go ahead and say that 5n to the 4th is what we're going to be using. So 5n to the 4th squared is equal to 25n to the 8th. So when we're rewriting this exact example, we're going to say 6 times 5n to the 4th squared plus 8 parentheses 5n to the 4th minus 15. And that's all we have to do. I'll go ahead and circle this because I got a little bit messy up there. So our final answer is in the black circle. So let's go ahead and look at example B. We have y to the 8th plus 12y cubed plus 8. And if we try to rewrite this, so say we have y to the 8th, and we try to rewrite this as y to the 3rd squared, these actually don't equal one another, and so this one can't be written in quadratic form. And so now you're going to actually see why we ever want to use quadratic form, and that's going to actually help us solve example 6. So in example 6, we have 18x to the 4th minus 21x squared plus 3 is equal to 0. So first, we're going to go ahead and we are going to say that 2 times 3x squared squared equals 18x to the 4th. So we can go ahead and rewrite our equation as 2 parentheses 3x squared squared minus 7 times 3x squared plus 3. And now we're going to let u equal 3x squared. And if we do that, we're going to just plug in a u anywhere we see a 3x squared. So we have 2u squared minus 7u plus 3. And now you can see how this is going to be a lot easier for us to work with because now we can actually factor this. So if we go ahead and factor, we're going to have 2u minus 1 times u minus 3 and now we can go ahead and solve. So in this case, if I solved for u, I'd add 1 to both sides so that I have 2u equals 1, and then I would divide by 2. So u equals 1/2. And here, if I solve, u minus 3 equals 0. I'd just be adding 3 to both sides. So u equals 3. But now, since we use that u value, we have to replace the u with 3x squared. So here we'll have 3x squared equals 1/2, and 3x squared equals 3. So solving for both of these, if we go ahead and divide both sides by 3 here, and I'm going to have to go over here because I'm out of room, we're going to end up with x squared equals 1/6. And if I take the square root of both sides, I'm going to end up with x equals plus or minus the square root of 6 over 6. Then for our second example, if we're solving for x, we can divide by 3 on both sides. So we end up with x squared equals 1. And if I take the square root of both sides, I'm going to end up with x is equal to plus or minus 1. So our solutions are going to be x equals plus or minus square root of 6 over 6, and x equals plus or minus 1.